So welcome to my session today. I'm talking about how we at Apollo are trying to transform the lives of farmers in Africa using Android. So I am Juma. I am a software engineer at Apollo. Sadly, my co-speaker could not make it today because his visa got delayed a lot. I want to virtually introduce Harun. Harun is the first Google developer expert for Android we have in Nairobi, or rather in Kenya. He wasn't able to make it today because his visa got delayed a lot. So what do we do at Apollo? So Apollo is on a mission to actually modernize farming in Africa for everyone. And for us to actually understand what we do at Apollo, let me take you about a few years back when Apollo started. So when our founders thought about building Apollo, one of the things they compared to was how is farming done in the US and how is farming done in Africa. And they broke it down into these small groups. And one of the issues they actually noticed is that there's not easy access to financing in Africa, and this means it's hard for farmers in Africa to actually get money to invest in farming and actually get high inputs. So that led to the birth of Apollo. So Apollo comes in to actually give farmers easy financing, access to farming tools and equipment, advise, provide insurance, and also provide easy market access. So I want to walk you through our customer acquisition journey so that my session makes sense. So the way we actually get customers to come in is we use local radio stations, farmer referrals, and all this is made possible to a small farmer who has what we call a feature phone, basically not a smartphone. So there's a code that you can actually dial. You more or less it's like you're telling Apollo you're interested in being a farmer with them, or someone can actually refer you. So that's the first step, which is like a self-sign-up step. And then once you self-sign up, you are actually assigned to an agent, like a field agent. So the field agent will actually use an app to come and collect data from you, and then that data is actually sent back to like our credit models and decision-making servers, and then they'll actually give you like a score. And then if you're approved as a farmer, we send you a voucher code via SMS, and you actually go with that voucher to what we call an agro dealer, and you can basically redeem it for farm input. So you can get your seeds, your fertilizers, and everything. And then after we give you that, we keep on sending you a lot of digital advice. So we use channels like IVRs, which is basically like automated phone calls that actually tell you, like, we're nearing this period, you can do X, Y, Z. So we try and give as much information to farmers as we can. And then the last step is normally the repayment period, which is after you harvest and you sell your product, now you need to pay back Apollo. So what does it mean for us as an Android team at Apollo? So we're fairly a very small team, only 2 engineers. And we at Apollo, we're like, Apollo is a very, it's intensely focused on using data to actually determine who we give loans to. And this puts pressure on the Android team because that's the only channel that the agents use to actually collect all this data from farmers. So some of the things that we're tasked with, or like most of the things that we need to do as the Android team is we need to make a very simple app that's easy to use because most of the agents that we use are not trained a lot to like use smartphones, so the app needs to be like super easy to use. We need to be able to change or like decide this is what we want to collect today and change that tomorrow, so we need to have a very dynamic app. And we need to make sure this app works offline, probably the whole day, and works on like very small or like low-end devices. So how do we do this? So we use JsonSchema, number one. So I'm just going, this is a definition of JsonSchema from the official website, which is basically, it allows us to annotate and validate our JSON documents. So the reason we actually adopt JsonSchema in our company is allows us to actually define specific data formats, and this makes it easy for the backend teams and the Android teams to actually collaborate easily. It also allows us to actually define very readable data formats that you as a person can actually read and understand. I'm going to show you a simple example as we move on. It's also easy to test, and it makes sure the client, or rather the Android phone, sends data back in the expected format to the backend. So the way we actually do this is we model this into what we call a task. So, so whenever you log in as an agent, we actually make an API call to fetch a list of tasks that is assigned to you. And each task can have as many subtasks as possible. So this is all in the context of Apollo. And then after we fetch that, that's saved locally on our database. So we created a sample task today. So an example of a task would look something, so the redacted things are just Apollo specific and not very relevant to the conference. But the way we'll do this is a task called DroidCon Berlin. So we're trying to create a task that we want to perform today. That's an example. And then the task actually contains a list of us. Sorry, it contains a list of subtasks, which basically looks like this. So this is like JsonSchema. And one thing we actually do a lot is, the beauty with this is we're able to actually give a version to every schema that we actually send back to the server, to the app. So for example, this is a form with a version 14, and then we can define which fields we want to actually make as required fields on the app. And then we can pass in a list of properties, which is basically the questions that we actually show or use to display on the app. So the reason we do this is because it allows us to actually predefine a question, what type of data we actually expect from this, and then we can use that to actually create UIs on the fly on the app. So like I mentioned, this is a normal form, but we support different UIs, so we can actually send a photo task to someone. We can actually send what we call a GPS outline or like an audio task to someone, and that renders differently on the app. So this is a sample form. And then the way we actually do this is we pull a task which has a list of subtasks. We actually extract the configs or like the subtask, which is a string. We save that on room as a text file, and then we read this back from. So whenever you're performing an action as an agent and you're offline, we actually query our DB. We get that config, and then we try to map it to what we call an Apollo schema, which is basically a data class that we serialize our data back into, and then our Apollo form, which is it's like an UI builder kit that we have internally, understands what the Apollo schema is, and then it's going to use that to actually render UI. So, like I mentioned, Apollo started a few years back, and the initial build of our app was actually built entirely in Anchor, which is deprecated right now. So Anchor made it easy, and it provided a very easy DSL for the engineers at that moment to actually use and build most of the views. So right now, we're in the process of migrating all this into Compose, and I will mention why. Because at some point, we're trying to move all this and our UI to actually have and maintain states. So Compose is one of the things that we're looking at in the future. So this is a sample of, I'm trying to see if I can explain this better, but on my right, so this is how we normally do it at the moment. So we read a schema, we read a config from the DB, we create a schema from it. From the schema, we can tell what kind of a field we're trying to actually create. And we have a NEPA function that once you pass in a schema, a key, if the title for that field and if it's a required field, it's actually going to return back a field. And then this is basically inserted back into a linear layout. I'll show you a screenshot of how this looks like. And the bottom part is what we call a conditional. We're able to actually send in, we call them conditionals, but they're basically conditions which allow a field to be visible depending on the state of another field. So for example, here, you only show this field if, So there's a missing snippet of code there, but it means that you should show this field if this field is also visible or has a value X. So able to control that on the fly. And on the other side is what we're trying to actually migrate to. So instead of creating fields on the fly, we're trying to create different states for different fields. And then we can actually pass in a couple of things. We can pass in the title to that state. We can pass in the keyboard type that we actually expect for that specific field and all these things. And we also can still maintain the conditional part of it. So this is how the app looks like right now. So on my father's right, this is what an agent would actually see, a list of 2 farmers. Once you click on one farmer, you're taken to a page which has a task on top. This is a field marking task, which is basically Apollo trying to onboard a new farmer to the platform. And then there's 3 sections, or like 4 grids. There's a grid with 4 cards, or like 4 views that you see. And the first one is a form. So that's the schema I actually showed. Sorry, that's a config I showed you like a few slides back. And then this is the picture one. We could have different ones, and whatever config we receive from the server determines what kind of a UI we're building. And then if you click on, say, initial questions, we show you, this is like the actual form. All this data comes from the server formatted as a JSON schema. So now the app has a way to actually understand what kind of a field we need, what validations are needed on the field, and is it a required field or not. So if someone fills in this and you skip a question which is like a required field, we can actually reference back and say, hey, you need to fill in this, or this is the minimum amount of numbers or like letters needed for this. And the last screenshot is basically, we tried to create a subtask for this conference, which is what I showed previously, actually, which is Berlin questions, are you attending DroidCon? And then the new approach that we're trying to actually do is we want to make the form very dynamic. So someone can actually break it down into a stepper. You can actually use the form as one list. Not sure what's happening. You can actually leave it as a list or like a stepper. So that's one of the things that we're actually trying to do at the moment. Okay, so now this shows us how we actually able to pull a config from a server, build a UI from it, but then we need to collect all this data back from the same form and submit it back to the API or something. So this is how now we do it. So for every schema that we read and we pass it to the UI builder. The UI builder has helper functions that actually allow us to read values back from each field. And then we save that back to room, and then we allow an agent to actually perform another task during the day. So for some tasks, like taking an image, we try save that image locally and then use the Amazon or like the AWS SDK to actually upload that. We get a URL and try post that back to the server. So we're trying to make it as simple as possible and making sure that if someone is not in a place where they have like good connections, they're able to actually pull data, perform the actions, or like do the everyday task and sync that back to the server. The other cool thing, or like the other interesting thing we do in our apps, so I mentioned we have 2 apps. The first one is majorly like the agent forecast app. The other one is the AgroDealer app that allows AgroDealers to actually check out farmers. Or like, so a farmer will give you a code, and then the AgroDealer will actually input the code and then check out them, basically meaning you give them seeds or fertilizers, whatever it is. So we built this cool thing that we call choice expression. It's basically like an advanced conditional that allows us to actually predefine things. So we could say, for example, you use it to build what we call a price calculator. So we give it inputs, and we tell it this is the output that we actually expect. And then when a farmer is actually checking out and they select, say your farm size is 5 acres, and you're selecting 10 kgs of seeds, and conditionals doesn't accept that, it's going to like give you an error. So the reason we do this is we allow actually AgroDealers to check out farmers when they're offline too. So the calculator is smart enough to understand this is not possible, this is possible. So this is like simple operations which we support, which is an ask. So on the UI, it looks like this. So this is an internal screen on the app, which is I used to debug the choice expression stuff, but we're able to build out views similar to this. So the conditional bit is like a conditional engine that we use to check the conditions if they're okay. And then we just use Anchor to build the UI, which is going to also move to Compose very soon. Some of the interesting challenges that we face is we're building up a very small app, and want to make sure this app works well in most phones. So when you're building for devices in Africa, most devices have low RAM, so you need to make sure our app is small enough and works well with smaller devices that have low RAM issues, smaller screens, low storage, which is an issue because we take a lot of pictures, limited on very slow connections, and we need to make sure we're syncing data back to the server. And one of the biggest issues we have right now is we're trying to use the ML kit to actually try improve how we take images for farmers, because the machine learning or like the credit scoring team use that image data to actually determine how much loan they give you. So these are some of the challenges that you're facing at the moment. Our future plans right now is we're already migrating to Compose. We want to move to a more modern serialization library. Right now we use a library called JobQ, which was an initial draft that the Android team, or rather Yigit, used to actually learn before they worked on Work Manager. So that's something else we're trying to actually migrate to. And last thing is we're also looking for smart engineers to come in and join us on this mission. So if you feel like what we're building at Apollo is interesting, you can always reach out to me. Yeah, and that's it for me. Thank you so much.